Thank you, Administrator Ruby. A paraphrasal of Abraham Lincoln strikes me as fitting here. The world will little note nor long remember what we say here, but it can never forget what they did at the National Ignition Facility. So let's recap. A team at Lawrence Livermore National Lab, National Ignition Facility made the following happen. There's a tiny cylinder here at the end of this that you probably can't see. It's about so tall and this wide. Inside that was a small spherical capsule about half the diameter of a BB. 192 laser beams entered from the two ends of the cylinder and struck the inner wall. They didn't strike the capsule, they struck the inner wall of this cylinder and deposited energy, and that happened in less time than it takes light to move 10 feet. So it's kind of fast. X-rays from the wall impinged on the spherical capsule. Fusion fuel in the capsule got squeezed. Fusion reactions started. This had all happened before, 100 times before. But last week, for the first time, they designed this experiment so that the fusion fuel stayed hot enough, dense enough, and round enough for long enough that it ignited, and it produced more energies than the lasers had deposited. About 2 megajoules in, about 3 megajoules out, a gain of 1.5. The energy production took less time than it takes light to travel 1 inch. Kind of fast. So this is pretty cool. I have a special message to listeners who want to work on exciting, challenging, and important problems. We're hiring. So, fusion is an essential process in modern nuclear weapons, and fusion also has the potential for abundant clean energy. As you have heard, and we'll hear more, the breakthrough at NIF does have ramifications for clean energy. More immediately, this achievement will advance our national security in at least 3 ways. First, it will lead to laboratory experiments that help NNSA defense programs continue to maintain confidence in our deterrent without nuclear explosive testing. Second, it underpins the credibility of our deterrent by demonstrating world-leading expertise in weapons-relevant technologies. That is, we know what we're doing. Third, continuing to assure our allies that we know what we're doing and continuing to avoid testing will advance our non-proliferation goals, also increasing our national security. The achievement we celebrate today illustrates that big, important accomplishments often take longer and require more effort than originally thought, and that these accomplishments are often more than worth that time and effort that they took. With that, I would like to welcome my friend and colleague, Dr. Kim Budil, the director of Lawrence Livermore National Laboratory, to speak about her laboratory's achievements.
Madam Secretary, Dr. Prabhakar, Administrator Ruby, and Deputy Administrator Adams, thank you for your remarks today and for your support. This is a historic achievement for the team at Livermore, our collaborators in academia and labs in the US and abroad, our industry partners, the fusion community writ large, and the many supporters and stakeholders in the National Nuclear Security Administration, the Department of Energy, and in Congress, who've ensured we could reach this moment, even when the going was tough. Over the past 60 years, thousands of people have contributed to this endeavor, and it took real vision to get us here. Building the National Ignition Facility was an enormous scientific and engineering challenge. I like Dr. Prabhakar's emphasis on the importance of bringing those two together. In the end, after all that work, the laser has exceeded its performance goals, opened whole new areas of high energy density science to exploration, and delivered the data we need to keep our nuclear deterrent safe, secure, and effective. Our pursuit of fusion ignition over the past decade at NIF was an incredibly ambitious technical goal. Many said it was not possible. The laser wasn't energetic enough. The targets would never be precise enough. our modeling and simulation tools were just not up to the task of this complex physics. Progress has taken time, but last August, when we achieved a then record yield of 1.35 megajoules, putting us at the threshold of ignition, many took notice. And last week, our pre-shot predictions, improved by machine learning and the wealth of data we've collected, indicated that we had a better than 50% chance of exceeding target gain of 1. 60 years ago, when John Knuckles and his team proposed that lasers could be used to produce fusion ignition in the laboratory, it was beyond audacious. The laser had just been invented and was far from the mature tool we know today. But this is really what national labs are for: tackling the most difficult scientific challenges head-on, learning from the inevitable setbacks, and building toward the next idea. Lawrence Livermore has been at the center of the ICF community across these many decades, and ICF has been a centerpiece of our lab. Indeed, people often say that LLNL stands for lasers, lasers, nothing but lasers. But I think our motto sums up our approach nicely: science and technology on a mission. This achievement opens up new scientific realms for us to explore and advances our capabilities for our national security missions. It demonstrates the power of US leadership in science and technology and shows what we're capable of as a nation. And as the Secretary mentioned, breakthroughs like this one have generated tremendous excitement in the fusion community and a great deal of private sector investment in fusion energy. But this is only possible due to the long-term commitment of public investment in fusion science. The science and technology challenges on the path to fusion energy are daunting, but making the seemingly impossible possible is when we're at our very best. Ignition is a first step, a truly monumental one that sets the stage for a transformational decade in high energy density science and fusion research, and I cannot wait to see where it takes us. Thank you.